What is the pressure drop due to the Bernoulli effect as water goes into a 3 centimeter diameter nozzle from a 9 centimeter diameter fire hose while carrying a flow of 40 liters per second? To what maximum height above the nozzle can this water rise? The actual height will be significantly smaller due to air resistance. Okay, so here is the fire hose. Okay, so this is 9 centimeters and this is 3 centimeters. Okay, so we'll call this point location 1, location 2, and what Bernoulli says is pressure at location 1 plus kinetic energy at location 1 rho g y1 and potential energy per unit volume at location 1 is equal to the sum of the same quantities at location 2. Now, so in the problem, what's implied is the level, it's a horizontal pipe. What is the pressure drop due to the Bernoulli effect as water goes into a hose? Okay, so that's the same. So this cancels that. Okay, cancels that. And the pressure drop is, okay, now since the pipe is smaller here, the water is flowing faster, this term is higher. Wherever the fluid flows faster, the pressure is lower. So this pressure is lower than that. Okay, so pressure drop is P1 minus P2. That's the pressure drop. We'll call it delta P, and that's equal to 1/2 rho V2 square minus V1 square. Okay, so the pressure drop, this point is at a higher pressure than this. The difference in pressure is equal to 1/2 the density of water times the velocities at this point and velocity at this point. All right, and they give us the flow rate. The flow rate is 40 liters per second, and that's from that flow rate we'll find the velocities. Okay. All right, so flow rate is velocity at location 1 times the area at that location. And that's equal to V2A2. Okay. So V1 is 40 liters per second. Okay, so V1 40. All right, let's add a page. So V1 is 40 liters per second, and a liter is 10 minus 3 meter cubed per second, and pi r1 square. R1 is the radius is 4.5 centimeters. So 4.5 centimeters, 10 minus 2 meters square. Okay, so this will work out in the meter square will cancel with meter square, leaving a meters per second. Okay, and so this works out to 10 minus 4. And so that gives you, when brought up, that becomes 10 to the 4, and 4 minus 3 is 1, so that makes that 400 divided by pi into 4.5 square per second. So V1 is 6.29 meters per second. So similarly, v to the velocity at this location, the flow rate is the same. Whatever water is flowing in here is flowing out. So the flow rate is the same as flow rate divided by pi r2 squared. Okay, so 400. So I'm skipping steps here, but anyway, 400 meters per second. The only thing that changes is the radius, and the radius was 1.5 centimeters squared. Okay, so all I did was change the radius from 4.5 centimeters to 1.5 centimeters. So 4.5 centimeters to that. Okay, so again, I've skipped a couple of steps, but it should be clear. 400 divided by 56.6 meters per second. So the velocity at that point is 56.6 meters per second. All right, now if you shoot the water at that speed, okay, so the water is coming at 56 meters per second. By the way, 10 meters per second is 25 miles an hour, so it's coming out at about roughly 125 miles an hour. To what maximum height above the nozzle can this water rise? So if you were pointing the nozzle up, what height can it rise is the question. Okay, so and that's still part B. Okay, so you're going to shoot something at 56.6 meters per second. Acceleration g is acting in this direction. What is the maximum height? So v square, we'll use this equation, v naught square plus 2a, and x is in this direction, x minus x naught. So x minus x naught, or the height to which the water climbs, is v square minus v naught square divided by 2a. And of course, at the top, the final velocity is 0. This is 0. Okay. So h is 0 minus 56.6 meters per second square divided by 2 times minus 9.8 meters per second square. Okay, let's add a paint below. And so this height will work out in meters, and it's equal to this works out to 163 meters. And as the problem states, the water of course won't go that high because of air resistance. 163 meters is 200 yards, so 2 football field lengths. Okay, that finishes that problem.